Okay, number four mirrors, I think the second or third example that I worked on the activity lab where I'm talking about the negative inequality. So I'm going to do a concrete and abstract at the same time. Uh, I'm going to move this 4x to the left. I'm moving all these integers to the right. But the way we do that is I don't want that 4x on the right side, so I'm going to make a copy and make them negative. Make a copy of that. Go over here, see if I can make the copy or not. There it goes. So what does it look like over here? Well, my line, minus 4x, minus 4x. Notice I kind of separate them over here because they will cancel here. I can't add these guys. This is not 13, it's not 36 or anything like that. It is two separate things altogether. Okay, so I'm moving them over just a little bit. One of these guys, oops, the previous example is there. Right there, and move over here to the right a little bit so you can kind of see what I did here. So you can kind of mirror what I have over here with the abstract. Bam, and that'll cancel out. I bring down then negative 4x minus 9 is greater than negative 1. Everything's negative. All right? No big deal. Now I can work it out. Like now it's become a regular two-step equation. I don't want that negative 9 on this side, so we'll make a copy. Bring it down, make it a negative, opposite of that negative, so it becomes positive. So it's really plus 9 on both sides. Plus 9, plus 9. That'll cancel on this side. I bring down that negative 4x greater than negative 1. Notice everything's negative again. And so over here, that is 0 out. These two are 0 out. And then that becomes 0. So I'm left with negative 4x is going to be, I don't know why I put a 1 on this side. See how, look, perfect. I made a mistake over here, but I'm able to fix it because I'm using manipulatives. It's not negative 1. Why I put negative 1, I'll be honest with you, I have no idea. But it's positive 8. So if you're watching the video, you saw me make an error, but fix the error because I'm using concrete objects, right? I'm using those tiles. So they're very useful. Nice little tools to use with our students. Okay, so I have now negative 4x greater than positive 8, but I have a negative, and I don't want that negative. Okay, one of the things we do when we teach this is we make sure you divide by that negative 4, and then all sorts of issues happen. Don't forget to flip. It becomes a nightmare. And if you're a teacher who's taught for a long time, you know that. But all I gotta do is this. Hey, I'm gonna go ahead and make you the opposite. I'm gonna go ahead and make you the opposite. I flipped it, and if you saw the video where I get the tiles and I flip them, that's exactly what I did. But since I flipped everything, that greater than symbol now becomes less than. So this becomes 4x less than negative 8. Now don't worry about anything else other than divided by that 4. So over here, divide by that 4, divide by that 4. X is less than negative 2. Here's my 0. Here's my negative 2. Open and shade to the left. And then you check. Is 0 less than negative 2? It's larger. You have the right answer. Let's come back over here, and then we just do this, right? We're gonna equally share that x. You should get negative 2. You get negative 2. You get negative 2. You get negative 2. And you get negative 2. Each guy gets negative 2. You're good to go. You're verifying. Tiles are a nice way to limit the errors at the beginning. At some point, we want them just here. Yes, I understand that. But this really helps here. And you just saw it right now in my example where I made a mistake here and put negative 1 for whatever reason. And then the error kids make, it's 10. It's negative 9. Because they're still understanding the rules for everything, right? The tiles help with those rules. And eventually they get it. They figure it out. And they stop making those errors.